In this video, we will cover the dynamic routing protocols. Guys, as you know, routers can perform routing operation in two ways: dynamic and static routing. Static routing allows routing tables in specific routers to be set up by the network administrator. This is something like you go to router and say, hey router, if you have a packet going to this destination, send it out from this particular interface and to this next hop, something like that. On the other hand, dynamic routing uses routing protocols that dynamically discover network destinations and how to get them. Dynamic routing allows routing tables in routers to change if a router on the route goes down or if a network is added. So in dynamic routing, routing protocols running in routers continuously exchange network status updates between each other as broadcast or multicast. So with the help of routing update messages sent by the routing protocols, routers can continuously update the routing table whenever a network topology change happens. Let's have a look to some of the terms used to describe an enterprise network infrastructure. In an enterprise network infrastructure, HQ, headquarters, branch offices, data centers, and internet edge terms refer to different components that play specific roles in overall system. The headquarters is the central location where the main business operations and core network resources are typically housed. It usually contains the primary servers, databases, and network management tools. Branch offices, on the other hand, are the secondary locations that are connected to headquarters via wide area network. So they typically have their own local network infrastructure but rely on headquarters for accessing central resources and the services. On the other hand, data centers are specialized facilities that house large-scale servers, storage systems, and networking equipment. So they are designed to provide high availability, redundancy, and scalability for hosting critical applications and data. On the other hand, Internet Edge refers to the boundary of enterprise network where it connects to the external internet. So it includes devices such as firewalls, routers, and intrusion prevention systems that manage and secure the traffic entering and leaving the network. In an enterprise infrastructure, commonly used routing protocols are OSPF, EIGRP, BGP, and RIP. So OSPF is a link state protocol and used for internal routing within an autonomous system, which provides fast convergence and suitable for medium to large networks. EIGRP is a hybrid protocol, which means it combines features of distance vector and the link state and used for internal routing within an autonomous systems and provides fast convergence, and it is suitable for again medium to large networks. BGP, that is a path vector protocol, and the scope of BGP is external routing between different autonomous systems mostly, and from convergence perspective it is slower compared to OSPF and EIGRP. On the other hand, it is highly scalable and used for internet routing. And the last protocol is RIP, that is a distance vector protocol used for internal routing within an autonomous system again, with a very slow convergence and limited to very small networks only. As you see, we have a lot of options from dynamic routing protocol perspective, but which one should I use? Okay, so to answer which routing protocol should I use question, we need to answer some additional questions as well. First of all, what is the size of the network? The size can vary significantly. For protocols like OSPF and EIGRP, they scale from small networks to large enterprise setups easily. The second question is, do I just use Cisco? Cisco supports multiple protocols such as OSPF, EIGRP, BGP, RIP. It supports almost everything. But if you are using any other vendor on your networking environment, you need to make sure that that vendor also supports the dynamic routing protocol that you are planning to use. Another thing we need to consider is the convergence time. So convergence time differs by protocol. OSPF and EIGRP generally converge quickly within seconds to a few minutes, while BGP can take longer. And the last thing to consider is scalability of the protocol. So OSPF and EIGRP are designed for scalability in large networks, whereas BGP, for example, is used for very large scale inter-domain routing like in the internet. IGP and EGP are fundamental concepts in network routing. IGP protocols are used to manage and direct traffic within a single organization's network known as autonomous system. Think of them as the rules and methods for how routers talk to each other and make decisions about the best path for data within one company or network. The commonly used IGPs are EIGRP and OSPF, and the use of RIP is very limited. ISPs also use ISIS, and that is an IGP also. EGP, on the other hand, this protocol is used for routing between different autonomous systems. They manage how data is transferred across different networks or organizations, facilitating communication over the broader internet or between multiple AS. So BGP is the only EGP used today, and the main functionality of BGP is to exchange a large number of routes between different autonomous systems. And we have routing protocol types, and there are mainly three routing protocol types: distance vector, link state, and the path vector. So in distance vector, routers periodically send their entire routing table to their neighbors, and each router updates its own table based on the information received, considering the distance, usually in hops, to reach the different destinations. So an example for distance vector protocol is RIP. It is mostly very simple and easy to implement, but it can suffer from slower convergence and routing loops. When it comes to link state routing protocols, here each router independently maps the entire network topology by exchanging information about the state of its links with all other routers in the same AS. So this allows routers to calculate the shortest path to each destination using algorithms like Dijkstra. So an example for this is OSPF protocol, of course, and this protocol, link state protocol, provides faster convergence and more detailed network information, but it is more complex and requires more memory and processing power. Compared to distance vector, guys, you don't really rely what your neighbor says in link state. Okay, here each router independently maps the entire network topology. And we have the path vector. Here routers exchange information about the path, a list of autonomous systems that data will travel through to reach different destinations. This helps preventing routing loops by keeping track of the AS paths that the data has traversed. So an example for this, and the only example, is the BGP, and this is used for routing between different autonomous systems on the internet, highly scalable, and provides detailed control over routing policies and path selection. So each of these types of routing protocol has its own advantages and use cases depending on the size and complexity of the network. And lastly, let's talk about the convergence. That is the time it takes for routers to notice the change in the network, to share information about the change with each other, and to make the necessary calculations to find the best routes again. Guys, convergence times in routing protocols really matters. First of all, it can provide minimized outages. Shorter convergence times reduce the duration of network disruptions, preventing data loss and service interruptions during network changes or failures. Also, it can provide you a faster recovery. Quick convergence allows routers to rapidly recalculate and establish new and optimal routes, ensuring that traffic flow remains efficient even after network topology changes. Also, it can provide stability and reliability. Rapid convergence helps maintain consistent and stable routing tables, which reduces the risk of routing loops and inconsistencies that can degrade network performance. So, in summary, faster convergence time enhances network resilience, reliability, and overall performance by swiftly adapting to changes. Okay guys, that's it from my side for this section. After this lesson, Udemy will ask you for a review for the training. I know it's a little bit early, but this is how Udemy works really. And if you enjoyed the training until now, I would be appreciated if you can rate with a good rating. And let's meet in our next sessions. Thank you so much.